Hello everybody, this is an extension 2 video. It is about the finding volumes by slicing. This is probably going to be a bad video because it's hard to draw on this thing in 2 dimensions and I'm about to try and draw in 3. So let's say, for example, that I want the volume of, let's just do one that we already know how to do. Y equals x squared about y-axis. About the y-axis, 0 to 2, I don't know, just for the sake of picking something. So all I really want to think about for this video is just what that looks like. So I'll draw a diagram the best I can. Pink, why the hell not? So there's my parabola, and the idea is that when you rotate this thing, here's 2, let's say, I get all these things like that. And we can think about all of these as disks that we create. So at some height y, which is a variable, I am finding the volume of this disk. And this is called delta V, right? It is a small volume, it is a change in volume. And the volume of this thing is delta y, right? This height here, sorry, is delta y, times the area of this circle, which is pi times the radius, and the radius is from there to there, which is x. Pi times x squared. Okay. This is, I'll write the answer down and rub it out. Right, this is why v equals pi x squared dy. Hopefully you can match things. Dy, pi x squared. Right? The technical reason is that this is a continuous thing. This is a discrete thing. Discrete meaning it has a length. So its length might be, 1 on 100 or 1 on 1,000 units or something. But I turn it from the discrete to the continuous. And how do I do that? And it turns out that you have to write all this stuff every time in Extension 2. You still do exactly the same thing you normally do in Extension 1 and Mathematics, but in Extension 2 you have to do this. So the full volume is equal to the sum of all of these delta V's. And the sum runs from y equals 0 to y equals 2. And moreover, it is, sorry, I forgot to squeeze this in, the limit as delta y approaches 0 of that sum. And it turns out that this is exactly the same as the integral from 0 to 2 of the delta v's with respect to y. Right? So basically exactly that. Sorry, that's really bad notation. Sorry, I'm going to rub that out. Not that. It is the delta v, but instead of delta y, we take the limit, and the limit of delta y is dy. That's exactly what dy means. And that gives us the usual formula, right? Around the y-axis, pi x squared dy. I'm going to do exactly the same thing with dx. Right, that's what we're going to be doing tomorrow. Obviously, there's a reason that we have this slightly new technique, and it's because we're going to be asked questions that are a little bit trickier than they are in Extension 1 and Mathematics, that really do rely on having this technique. I really need some photos from you guys. I have none, so you need to lift your game. Please send me one tomorrow. See you bright and early.